Good afternoon. The task that I was allotted was to build a resume parser and keyword matching algorithm using BERT or cosine similarity. The following slides represent the basic methodology and how to execute the project stepwise. So, the first step is to understand the problem. The goal is to automate the resume screening process by doing four important things. The first one is to extract key details from resumes. These include finding the name, experience, and educational details and skills. The second one is to extract key job requirements from job descriptions of resumes. These include things like skills, qualifications, and experience. The third one is to match resumes to job descriptions based on semantic similarity. Now, this is something which means how well a resume fits a certain job. And the fourth one is to rank resumes based on similarity scores so recruiters can prioritize top candidates. So basically, while trying to do this assignment, I stumbled upon the following challenges. The first thing was basically that resumes exist in different formats. For example, you have PDF, document format, and text format. So all of these formats have to be read equally well by our parser. Second one was job descriptions are usually unstructured, so they have to be structured well and have to be cleaned thoroughly in order to match and do all of the extract all of the skills and qualifications. And of course, the approach that we used for this assignment was first and foremost to use natural language processing, NLP, to extract and compare relevant information. Now, basically, in NLP, we implemented different text similarity algorithms. These included algorithms such as TF-IDF, and cosine similarity for ranking. And we also built a web based system to understand and to allow recruiters to upload resumes and job descriptions. Along with this, other kinds of challenges that I encountered was that resume matching should be extremely accurate, considering synonyms and related terms. For example, if you have something such as AI and machine learning, those have to be recognized as related skills, and all of these have to be properly done and structured in order to uh, carry out the whole process. Okay, the second step was basically data collection and pre processing. Now, in this step, before we start to actually process the resumes, we need to extract the data and clean it. So, the first step that we use for this is resume data extraction. What we did here is, since resumes come in various different formats and we have to basically recognize all of these formats in our assignment, we used different Python libraries for extraction. So for example, the kinds of formats that we kind of trained our model for are PDF, document, and text formats. So for PDF, we use the libraries called as PDF Plumber and PyPDF2. For document format, file format, we used a library called as Python Docs, and for text format, we just use standard Python file handling libraries and commands basically, which include open and read commands. These are sufficient for reading text formatted documents or files. Okay, now the following basically shows a small example of how resumes can be extracted from different file formats. So the first one includes extracting text from PDF file formats. So I'll just basically explain the code in brief. To first extract text from PDFs, we need to import the library. Library which I have used here is PDF Plumber. So we have imported PDF Plumber library. Then we have defined functions here, and in both the examples we have defined a similar function with slight changes in their code. So the first one is defining the function called as extract text from PDF, and this also specifies the PDF path which is mentioned inside the brackets. Now, along with this, we have mentioned what kind of text we want to extract from the PDF, And so with the help of this code, with the help of the for loop, which basically detects which page in the PDF to extract text from, we have used this to extract text from the PDF pages. And the text plus is equal to page dot extract text is the code that is used to extract it, and the return function basically returns the text which we have used. The second example is extracting text from a document formatted file. So for this one, we have used a library called as document. So we have imported the document a library, and then we have defined a similar function which is define extract text from docs. So this function basically helps us to define extracted text from document formatted files. Then we have also mentioned the path of the document inside the brackets. And similar to the previous code, the document function basically helps us to define and basically define the path of the document, and so on and so forth. The second step, which is very important here, is text pre-processing. Once we extract this text, we need to clean and standardize it for efficient processing. Now basically this pre-processing includes the following key functions that we have to perform. The first one is lowercasing. Now lowercasing is something which basically converts text to lowercase for uniformity, and this is an essential feature for data handling and for data analysis in all kinds of applications, because usually text in resumes, for example, come in various different fonts and formats. So we need to convert them into all lower cases so that it's easier for the computer to process it. The second one is removing stop words. Now stop words are basically words that include, for example, the, is, and even the word and. All of these words usually don't add much meaning into the document or the resume, but they just occupy a lot of storage, and they're just there to enhance the meaning of the overall document. So removing stop words, there's a function for this which basically removes and eliminates words such as these. The third important function which we have to perform is removing special characters. Now, special characters also occupy a lot of storage and a lot of data inside the system. So basically we need to strip out punctuations and symbols, all of these things which enable us to efficiently handle the data. The fourth one is tokenization. Tokenization is something which basically splits text into individual words or sentences. Now this function or this feature is extremely important in any data analytics program, because many sentences come in large paragraphs and large sentences which are harder for any Power BI or any Tableau or any data analysis platform to break down into. So all of these large paragraphs must be split down into smaller words in order to easily recognize and analyze the data. The fourth one is lemmatization, which basically converts words to the root forms. This is also a very essential feature because words must be converted to their original root forms to again reduce storage and efficiently manage data. There's an example here which we have used for cleaning the data text using a model called as spaCy model. For this, I'll just briefly explain the code. We first imported the spaCy model, and then we have used something called as stop words, which removes all of these stop words which don't add meaning into the data. Then we have defined a function called as NLP is equal to spaCy load, and this is a built-in function for spaCy models which is Encore Web SM. This basically helps us import and conceptualize NLP models into our data platforms. Then we have defined a function called as pre-processed text, and we have used a variable text here, and basically this helps us define different pre-processing data texts into all of these. For example, document process text, and then we have returned that function. So for the document function, basically we have used lowercasing over here. So we have used the NLP function and text.lower code to lowercase all of the letters which are present inside the resume. Then we have used the process text code. This code basically lemmatizes all of the words inside our resume. So it removes all of it converts all of the words into their root forms. So what it does, the code here is token.lemma for token in doc, and this code basically helps us lemmatize all of the words which are present inside our resumes, and of course which are also not there in stop words, and then we return the function. Now the third step is resume parsing. This is a very important function, and this is the main key function of this whole task, and this extracts key information from our resumes. So what are we exactly doing here? We are extracting specific details from resumes, and this includes the following. So first, we are extracting data such as personal information, and this includes something like the name, email, phone, location, and maybe the relatives, and all of these kinds of details of a particular candidate. The second detail is education, which includes details like the degree, the institution, the year of passing, the year of entry, and so on and so forth, certifications, all of these kinds of things. The third one is the work experience, and this includes details such as the job titles which the candidate has worked in, and other companies which they have previously worked in, maybe their internships, their years of experience, and of course how well versed they are in a particular field. This basically shows that. And the fourth one is skills. So basically skills shows the kinds of skills that they are proficient in. So these could include different programming languages, different frameworks, tools, all of these kinds of things, and maybe also different kinds of features they're familiar with. All of these basically show their skills, and this is what we need to extract. So the first step which we will be doing here is called as named entity recognition, NER. NER basically is a kind of a model that helps us extract structured details from unstructured resumes. Now we all know that resumes are quite unstructured for the computer, not for us, for the computer to basically extract data from. So what we are doing here is we are helping the computer to structure it, and we are using NER models for that. The fourth step which we'll be carrying out is job description processing. Now this is also a key feature that we must carry out in this whole task, and what we are doing here is we are extracting key job requirements. So this includes mainly three steps, which is extracting and cleaning job requirements, and then identifying key skills, and converting job descriptions and into numerical representations. So first and foremost, we'll use an NER model and keyword matching algorithm to extract relevant skills. So the following code basically helps us do that. So as you can see, I'll just basically describe the code here. We're defining a function called as job description, and this basically where it outputting a certain sentence here. I have just added here, we need a Python developer with experience in machine learning, TensorFlow, and whatever. So basically whatever skills we want, we can just use that to output a certain line of code. And then we have defined a function called as doc here, and basically this helps us retrieve job description through the NLP model which we previously built upon. And then for the for loop over here, for token in doc, now what this is doing is tokens are basically converting. Tokenization is, as I had said earlier, tokenization converts large sentences and paragraphs into smaller words. So we have used those tokens which have been previously converted into smaller words, also known as tokens, and we're using that as a parameter here in the for loop. The for token in this particular document, which is the doc, if token.position is equal to noun, then we are printing that token text. So this is what we're doing here. We are basically finding the position of the token, and if it's matching our required criteria, which is basically a noun here, any skills or whatever we want to retrieve, we're using that as a criteria in the if condition, and we are printing that particular token text into our document. So this is a very important function that must be carried out in order to extract whatever skills that we want into our system. Now the fifth step is basically the main crux of the whole task, which is the resume matching algorithm. In this step, basically this step involves two major things. We are converting the resumes and job descriptions into vectorized representations, and we are computing text similarity to rank the resumes. So let's first convert them into their numerical forms. Now for this, I have used an algorithm, something called as TF-IDF vector. This basically helps us convert any text into numerical forms, which basically sounds wild, but it's possible in NLP systems and NLP models. So this is done over here now. So the following code briefly explains how it's done. So we are importing two different libraries here which are essential and which are crucial for carrying out this task. The first library is the TF-IDF vectorizer, and the second one is called as cosine similarity. Now both of these libraries are extremely important for us in order to carry out this vectorization of the text. So what we are doing here is we're basically defining all of the different keywords using the document function. So over here I have defined Python, machine learning, data science, Java, Spring Boot, microservices, and so on and so forth. You can define anything that you want, or basically whatever is required by the certain organization. Then we have vectorized this using the TF-IDF vectorizer, and we have put this into a matrix. So TF-IDF matrix basically helps us transform these documents which is present there into our code. So yeah, that's it. The second step is basically BERT embeddings for semantic matching. Now, BERT basically is a kind of an algorithm which understands contextual meaning, making it much more effective than TF-IDF, for example. So what it's doing here is it's converting and it's basically conceptualizing the data from the resumes. So over here we have imported two different libraries again. As previously we have imported cosine similarity, and along with that we have imported something called as sentence transformer. Now sentence transformer is a library used for BERT embeddings. We have defined a model here called as the sentence transformer, and this is the usual model that we usually import. Now we have defined a function for resumes, and we have output a certain feature here, and basically this is how BERT embeddings is usually done. The sixth point over here which we have to carry out is the resume ranking system. This is also a very important function which basically helps us rank resumes and score and display top rank candidates. So for example, over here we have output three different candidates which match the highly requested, and like which match the first three top skills that we need. We can basically output any number of candidates based on the job openings, for example, or based on the need of the company, and so on and so forth. So these three candidates, for example, John Doe, Jane Smith, and Mike Ross, are the ones which highly satisfy all the requirements that are required for the particular job opening or the skill, and they have the highest match scores. The last step which we are doing here is deployment, and to make this a functional system we are deploying it with basically, as any system, we need a backend and a front end for this. So for backend we can use Flask or Fast API to handle the processing requests. We are using here Flask. And for front end we need a basic front end developer, so we're using React.js. Django based system can also be used. Databases, we could use MongoDB or PostgreSQL, because all of these are non-SQL type data structures. And the final one is cloud deployment. This is basically very essential for companies or systems which require very large resumes and large data sets. So anything could be used: AWS, Google Cloud, or Heroku for hosting. For this system we actually don't need one because it's a smaller data set, but for larger systems and larger ATS tracking systems we need larger databases and cloud deployment models in order to store sufficient amounts of data. So this is also an important feature that must be present in very large organizations. Coming to databases, of course, we're using here MongoDB, as it helps us also identify non-structured, non-SQL based data. Alright, the data set that we have used here has been created through coding by Google Colab. So I basically coded a basic data structure in Google Colab, and I've basically produced a small CSV code which helps us produce the CSV file for it as well. So as you can see here, we have defined various functions such as the name, the educational details, the skill set, all of these into our Google Colab notebook. And we have imported the basic libraries here, which is random and pandas, which is this which is the classic basic library used for all data sets. So we have defined different functions and different requirements for all of these fields. So I have used around 10, which sums up to around 100 scores. You could use as many as you want, and I've added just random names over here in the name, educational levels, and skills. Along with that, we have also used different fields such as certifications of the candidates, the project list, and also their work history list. All of these are important features that must be used in any data set. Now, this code basically helps us identify and define the data set, and it also helps us sum up and put all of the fields that we have used into one CSV file. So the above code basically is defining all of the different fields that we previously used, which is the name, education, experience, skills, and so on and so forth. Then we also have something, this last line of code, which is define large to CSV. We named the code first of all, and after that we converted it into a CSV file. This is important because in any Google Colab notebook, I have used Google Colab here, but in any data set, a CSV file is extremely important for us to carry out all of the data analysis and to also parse through the data effectively. So this code here helps us convert that. Now this is a sample image of the data set which was produced in the CSV form. And this was the code that I previously used here. So as I had said earlier, the last line of code helps us convert this into this particular data set. Now, let's come to the execution of tasks. To execute these three steps, which is basically resume parsing, matching, and ranking, the following method has been used. So first and foremost, as I said earlier, we had to use a lot of libraries for this. So I didn't have many of these, so I had to install all of the required libraries. So over here, I installed the Spacy model, which is an NLP model that allows us to successfully execute the data. Along with that, I had to also import many other libraries, for example TensorFlow. I had to import a BERT embedding algorithm models, and I also had to import TF-IDF vector models and all of these. The second step was to upload the data set in Google Colab. So for data analysis, any platform could be used, the common ones, but I use Google Collaboratory or Google Colab Notebook for this particular task. So for that, as I had said earlier, the data set was converted to a CSV file. So that had to be uploaded into our Google Colab notebook. And I used the following code to upload that. And this is really important for us because it helps us easily read and parse through the data and helps us, follow the code and report it into the data set. The third step which we had to do was to load and preview the data set. So this basically helps us gauge an overall idea and just gain a basic understanding of what the data set looks like. So we read through the dataset elements and we previewed it. So we used the following codes to do that. So first one was to define the head and the basics, the basic features which are present in our data set, and the output for that is as follows. It displayed the name, the education, the skills, the project list, the work history, the experience, the certifications, all of these for the data set. So it's useful for external users. The fourth step was resume parsing using NLP. Now this code was extremely important. I have explained this code previously, and this basically helps us parse through the resumes in Google Colab itself. So in Google Colab, I typed through this code, and this basically helps us parse through the whole resume, and when it has extracted all of the fields into Google Colab, it reads through that and parses through that, and it helps us find out what we require using the NLP model. So we have used here Spacie model to do that, and Spacie library to do that, and it helps us basically read through all of the different fields. So for example, we have used here name, experience, skills, and education, but whatever that is required by the company or the producer can be used, and this helps us parse through and navigate through the whole data set easily. The second step which we have done here in parsing is cosine similarity, and this basically, as I had said earlier, this is like the TF-IDF vector. I have explained the code in detail, and this helps us find the similarity, the most matching similarities of a particular skill to a particular job role. So over here we have defined different functions here, the document function and all of these vectorizer, TF, IDF matrix. This basically puts all of the vectorized data bits into a matrix, and then it also helps us perform cosine similarity. So all of these functions are important in order to find out and rank the important skills that we need. So this was the output. This is a sample output. I have produced here the first 10 cosine similarity matching algorithms. The company of course can use as many as they want. The last step, the last requirement of this task was to rank resumes which were the most matching resumes in the whole of the data set. So this particular code here, I have used the following key fields to be displayed into the output, which is the name, the experience, the education, skills, and of course their match score. But as many as fields which the producer or the company wants can be displayed, and along with that the number of fields which basically is present in the head. I have included here 10, but we could include as many match scores as we want based on the particular job opening, and it displays those number of match scores. And this is a sample output of how all of the ranked resumes can be performed. So as I had said earlier, if it's 10, it produces 10. If the job openings are maybe 3 or maybe 5, or even if it's 1, we can just enter that particular number into the head field and inside the bracket, and it will display whatever number of fields or match scores we want for the particular application, and it will help us gauge which ones are the most highly matching candidates for a particular job role with respect to how many ever job openings that are present inside that company or field. Or if we want some other, for example, skill, we could also insert that, and based on that it will help us gauge who have the most number of skills or who have the highest matching score for a particular job role. And of course this can be modified based on different criteria. We can use skills, we can use work experience, we can use certifications, all of these various kinds of criteria to basically filter out and bring out the highest match scores. Now the following shows a sample front end of the whole document. I needed to produce something which will help us basically input the data into the whole task. So I created a sample front end for this, and I used Django as I'm familiar with Django from all of my previous years of CSC. So the first one, this is basically a views.py file, and it basically helps us define functions of the particular task. So we have defined the main function which we have defined here is match resumes, and we have imported a request for that. And of course we have imported all of the libraries which we previously imported even in our Google Colab. So sentence transformers, pandas, torch, all of these are important libraries, as well as standard libraries for views.py are also included here, which includes import render, import API view. All of these are important things that have to be used in the views.py. And of course we have defined a function for reading the CSV files and modeling. We have defined the model, which is the sentence transformer. And of course resume embeddings, which includes model encoding for the whole resume for the whole resume that has been imported here. And of course there are other features as well, such as stop matches, top matches in the last few lines basically helps us find the similarities, and then matched resumes basically helps us define the location and find out the most returned response of this.